This hit and run is about Excel regression and a trap. Yes, you can do regression in Excel, and there is a trap that's somewhat related to that. This is the story of someone who went home on an early break and decided to impress his relatives who ran the family small business with his econometric skill. He was going to show them how effective their advertising was. And so he got data from the cousin who did the bookkeeping on advertising and sales. This is all in millions of dollars for that small business, and proceeded to do a regression. Let's see, just a little review here of how to do it in Excel. We go ahead and go to data analysis, and since that was already installed as an add-in, we pick regression. There's that. And now what we got to do is input the Y range. This is the dependent variable, the thing that we're trying to explain. And there that is. It is sales. And then here we have the explanatory variable, the thing that in this assumption caused sales to take on the values that they did. So we've got advertising and sales put in. And if we just pushed OK here, we would get the regression, but let me show you two tricks that'll save you some time that this student, being a good student, applied. Click labels right there, and that's because in C1 and B1 we have labels, advertising and sales variable names. If you don't do that, you'll get a non-numeric data error. If you do that and include those labels in the range and tick the labels box, then you'll get your results labeled. And then line fit plots. It's not something you have to do, but this will be a big help in doing a nice graph when everything is done. So we hit OK, and we get regression results and a line fit plot. Let's blow up these results here and see what's going on. Ooh, look at that. That's the R squared 0.95. That's a number we want to remember. There's the intercept, $1.2 million. And then there's an advertising coefficient of about $22, and there we go, almost 40 cents. So let's go over and have a look at what our student home from break was able to write out. He was able to write out, hey, look, everybody, sales hat, the estimated sales there are equal to $1.21 million plus 22.4 times advertising. Look at that. That is, for every additional dollar of advertising, you get almost $22.40 in additional sales. And at this point, the cousin who's the marketing director is out in the yard dancing. Wow, we are great. Look at us. We are so great because we can take $1 of advertising and turn it into $22.40 worth of sales. And of course, that is one interpretation of these coefficients here. And then the line fit plot, you notice that it was over to the side. If we right click that and apply all our pretty formatting to it, then we get this. Just a very nice graph of the advertising sales relationship. And so this just really looks wonderful. And the R squared is 0.95. And our student home on break explains that that's the coefficient of determination. The coefficient of determination of the R squared, really people only call it R squared. You hardly ever hear it called the coefficient of determination. But look, it's got to be between 0 and 1. 1 is the highest it could be for a perfect fit. 0 is the worst it could be for a fit that didn't explain anything. And look, it's 95% as good as a perfect fit. And so when the diagram gets drawn out, it looks like this: sales on the vertical axis, advertising on the horizontal axis, and those data points were plotted from the cousin, the bookkeeper, what was provided by that person. And then Excel, in effect, drew the regression line to go as close as possible to as many points as possible. And this is not even to scale. That line is so steep because every time it had a delta X of $1, $1 of additional advertising here, sales went up by $22 and about 40 cents like that. So you notice that was the delta Y. So What this student has done then is to make the statement that every dollar of additional advertising leads to $22.40 in sales. And this is where the student got it backwards. Because after all the celebration about how good their advertising is dies down, the old wise uncle comes up and says, you actually got it backwards. Oh, how could that be? Got it backwards? Yeah, it's not true in our business that advertising causes sales. In fact, it's sales that causes advertising with a 1-year lag. Hey, what's that? Yeah, every year we find out what our sales are, and we take 4.5% of that and allocate that next year to the budget to be our advertising budget. So you see, it's not that advertising causes sales, but instead that sales cause advertising with a 1-year lag. What is the trap that our young student fell into? The trap is the wrong causality assumption. And I will just point out here that a high R-squared does not prove you right. It just shows a very good fit of the data with the wrong causality assumption. And that is the hit and run on Excel regression and a trap.